This is the Math 7 Unit 4 study guide talking about equations, expressions, translating, solving equations, modeling equations, etc. The first topic in this unit talks about translating, taking English words and writing them into math symbols that essentially represent the same thing. 8 less than a number is 25. One of the keys to circle the word is 25 is equals 25. Less than is one that means subtraction. You can guarantee you'll see it on most of the summatives. Less than means subtract, but also means flip. 8 less than a number is 8 less than a number. It didn't say what the number is. You're not choosing a number. You're not writing a number. You can choose the letter that represents your variable. Of course, you could write a picture. Less than flips the subtraction. It does not flip the entire thing. Negative 8 doesn't go all into the end. It's just 8 less than the number. These two things. It's 8 less than a number, so the number part comes first. That should be written right there. The difference of twice a number and 7 is 12. So I have is, circle my is, it's equals 12. Difference means subtraction. The difference of twice a number. Twice a number is not x squared. That's not twice a number, that's squaring a number. Twice a number would be 2 times a number. That's double it, twice a number. So the difference of twice a number and 7, the difference between twice a number and 7 is 12. If you look at number 3, there's no is, so it's not going to be an equation or an inequality, it's just going to be an expression. The sum, which means addition, the sum of a number squared, so this is where we could have a number squared and 1. The sum of a number squared and 1. Of course, it's different than the square of the sum. If instead it said the square of the sum of x and 1, that would be the square of the entire sum of x and 1. This is different. This is saying you're squaring the entire sum. So you're squaring the entire sum. Here, you're summing, you're adding the number squared and 1. This, you're squaring the entire thing, the entire sum. That's why we need parentheses. This is just like the distributive property. It's not the distributive property, but it's like the distributive property. It's different than number 3. Anyway, this is just a bonus. This is the answer for number 3. For number 4. Negative 45 less a number, here's the word is the square root of 2, is the square root of 2. So negative 45 less a number. Less is different than less than, which is also different than is less than. Negative 45 less a number is the square root of 2. Number 5, again, no is, it's just going to be an expression. The product of a number and a different number. Product means multiplication. So the product of a number, we'll call that number f, and a different number, we'll call that q. fq. Could I do f times q? You sure could. You don't have to. We just do fq. Number 6, we're looking for the word is. There is no is, so it's going to be an expression. The quotient, which means division, not multiplication, the quotient of 15 and a number. Or you could have wrote the quotient of 15 and a number. Could you have done k over 15? No. Could you do k divided by 15? No. They need to be in the order in which they say they are, because there is no commutative property of division. There is a commutative property of addition. You could flip-flop addition if you want to. You could flip-flop multiplication if you want to. But you cannot flip-flop subtraction or, in this case, division. Number 7, again, no word is, so it's going to be an expression. A number tripled. A number tripled is not a number cubed. That's a number cubed, or a number to the 3rd power. A number tripled is times 3, multiplied by 3, increased by 33. Again, no word is for 8. But there is that word less than. 14 less than is 14 less than. It's less than, 14 is less than half of a number. Well, half of a number, we could do k divided by 2, or we could do k divided by 2, or we could do 1/2 of k, that's half of a number. 14 less than half of a number. 14 less than half of a number. 14 less than half a number. The numbers being halved, not the 14. Number 9 is says to label as an inequality expression or equation. We'll do all these and I'll do a couple bonus questions for you. A is an equation. D is an equation, equal sign, equal sign. G is an inequality because it's got an inequality symbol. This B is an inequality. C is an expression. I probably should go across. Let me go across. A is an equation. B is an inequality, inequality symbol. C is just an expression. It's got math operations, addition, and multiplication. Specifically, it's an algebraic expression if you want to get technical. D is an equation. It's true. 5 plus 3 equals 8. E is an inequality because it's got an inequality symbol. In this case, D is less than or equal to. F is an expression because it's got multiplication, addition, multiplication, addition. Specifically, it's an algebraic expression because it has variables in it. Question G is an inequality, inequality symbol. It is true. H is another expression, and once again is an algebraic expression because it has a variable in it. And I is an inequality because it has an inequality symbol. So let me do a bonus one for you. What if it were 9J, and 9J was the number 6? Would that be an inequality, an expression, or an equation? Well, it's just the number 6. It's actually a trick question. It's none of those things. Let me do question K. What if it were 2 plus 3 equals 10? Well, it looks like it'd be an equation, but 2 plus 3 is not equal to 10, so it's not true. So once again, it's a trick question. It is none of those things because it's not an equation. It's not a true math statement. 10 says to examine the equation below, then answer the following. How many terms are on each side? Well, we know that terms are separated by plus signs, minus signs, and equal signs. So here's a term, here's a term, here's a term, and here's a term. So 2 on the left and 2 on the right. List the 3 coefficients. Now, coefficients are co-workers. They work with a number. The first one should be pretty obvious. The coefficient is 5. The second one is just n, so you might think, well, there is none for n, or you might put 0. That would be incorrect because 0 times n would be 0 and it'd go away. So what number is written right there? It's kind of hidden, but it's the number 1 because 1 times n is just n. That's called a multiplicative identity. This is not, it doesn't have a coefficient because it's a constant. Here's another coefficient. You might say that the coefficient is 3. That would be incorrect. The other coefficient is a negative 3 because it's a negative 3n. You might say that's subtraction. Well, to that I would say keep, change, change. Now it's plus a negative 3n, as you can see. Again, negative 3 when you do keep, change, change is your coefficient. C, are there any constants? The answer is yes, there is a constant. What is the constant? It's just this term, negative 4 is my only constant. 11 says to create a numerical expression that has at least 4 terms. All the ones that we did up here, this one, this one, this one, these are algebraic expressions because they contain variables. A numerical expression only has numbers. So we're going to create a numerical expression that has at least 4 terms. At least 4 terms, can't have more. I'll do a very simple one. Here's a numerical expression that has at least 4 terms. 1 plus 2 plus 3 plus 4. 1, 2, 3, 4 terms. That's a term, that's a term, that's a term. I could have done 1 plus 1 plus 1 plus 1. That's 1, 2, 3, 4 terms. If I want to get fancier, I could do 2 times 3, that is 1 term. Plus 5 squared, that's 1 term. Plus 8, that's 1 term. Minus 10, that's a term. Again, you might say that this is 2 totally different terms, but it's not. Terms are held together by multiplication. They're separated by plus signs and minus signs. So here's a term, and here's a term, negative 10. There are 4 terms. That's a numerical expression that has at least 4 terms. Number 12, says to create an algebraic expression with at least 3 terms. I can do 2x squared minus 6ky plus 10. This is an algebraic expression that has 3 terms. You might say, well, there's more than that. Nope, this, separated by a subtraction sign, this is 1 term. This, all held together by multiplication, negative 6ky, that's 1 term. And this constant, that's 1 term. I could have done more because it said at least 3 terms, but I only wanted 3 to save myself some time. This is an algebraic expression that has at least 3 terms. You could have done something simple and just done this, x plus y plus z. 1, 2, 3 terms are over. You could have even done x plus 2 plus 4. Because this is a term, this is a term, and that's a term. These are all examples of algebraic expressions with exactly 3 terms. We're going to solve and check these guys. Up until down here, these 6 examples are all one step. So let me bang out these one steps. Remember, in order to solve an equation, what you need to do is figure out what was done and undo that. In this example, someone took my x and added 7. How do I undo add 7? Subtract 7. I need to subtract 7 from both sides because it is an equation. Both sides need to be treated equally. X plus 7 minus 7 is just x. 12 minus 7 is 5, so x is 5. We're going to check. Now, it's already written check, so I don't have to write the word check. How do we check? We write our original equation, and we plug in using parentheses, just like we did. Excuse me, whoa. Way off on that one. Everything stays the same. Getting a little ahead of myself. Everything stays the same except instead of x, we put a 5 and we use parentheses. Just like we did on the previous unit, we plug in using parentheses. 5 plus 7 is 12 equals 12. When you get the same number on both sides, we know that it's true. 12 equals 12. So what is my answer? Is 12 my answer or is 5 my answer? 5 is my answer because this is the number that I plugged in that made it work. 12 is just my check. The number at the end of the equal sign is not always the answer. In this case, it's the circle thing, x equals 5. Moving over to the right, what happened to my d? Someone subtracted 8. How do I undo subtract 8? Add 8, and I do it to both sides. D equals 20 plus 8 is 28. Circle your answer. When I check, I write my original equation. Everything stays the same, except instead of where I had d, I use parentheses and I plug in 20, and I actually do the work. On the right-hand side, I just bring down 20, but on the left-hand side, 28 minus 8 is 20. 20 equals 20. That is true. So my answer is 20 or 28? Again, it's 28. The circle thing is my answer. What did someone do to my g? Someone multiplied by 5. You don't undo this by subtraction. Please don't subtract 5. I see that too often. You don't undo multiplication by subtraction. Again, you have to know what happened to the g. Someone took my g and multiplied them. We know it's 5 times g. The opposite of multiplication is not subtraction. The opposite of multiplication is division. So I undo the multiplication by dividing by 5, dividing by 5. G equals negative 25 divided by 5 is negative 5. Again, you gotta know how to work with integers. That's why we do all that extra work with integers. If you don't know how to work with integers, you're going to struggle all year long. When we check, we write the original equation. Everything stays the same, except instead of g, I put my answer, which is negative 5. And then I actually do the work. This just comes down. Negative 5 times 5 is negative 25. Same thing on both sides. Check mark, so negative 5 is my answer. Over here, what did someone do to my m? They divided by 3. Most students know this. The opposite of division is multiplication. So instead of dividing by 3, I'm going to multiply by 3, multiply by 3. Don't do it in your head and think that the answer is 4. You might say, oh, I can clearly see that the answer is 4. And you might say, well, 4 is the answer. 3 divided by 4. Well, if you plug in and you check, m divided by 3 equals 12. Is 4 divided by 3 equal to 12? 4 divided by 3 is 12. And if you do this, then you're definitely going to get it wrong because 4 divided by 3 is not 12. You're going to lose a lot of points because you didn't solve correctly and you didn't check correctly. Let's actually do the work. Undo multiplication with, division with multiplication. M equals 36. Now let's check that. Write my original. M divided by 3 is 12. Everything stays the same except instead of m, I put 36. What is 36 divided by 3? If you got to do the work on the side, do the work on the side. Top goes on the inside. 3 goes to 3 once, it's 3. 3 goes to 6 twice, that's 6. So the answer is 12 on the left, 12 on the right. Yep, 36 is my answer. With this one, again, we're working with integers. Someone took my r, subtracted 3, so I add 3 and I add 3. Gotta know how to work with integers. These numbers fight. The positives win by 1. I believe the answer is r equals 1. R minus 3 equals negative 2. Everything stays the same, except instead of r, we put 1. 1 minus 3. Keep, change, change. They fight. The negative win by 2. Negative 3 is negative 2. Check. Last one step for now. Y plus 7 equals negative 1 minus 7 minus 7. Y equals negative 1 minus 7 is not negative 6. Don't try to do it in your head. It's keep, change, change. We don't do subtraction. 1 negative plus 7 negatives. Again, 1 negative plus 7 negatives work together. That's 8 negatives. Got to know how to work with integers. Y plus 7 equals negative 1. Everything stays the same, except instead of y, I plug in negative 8. The right-hand side just comes straight down. Let's do this actual work. We like addition. They fight. The negatives win by 1. Negative 1, negative 1. My answer is, in fact, negative 8. All right, now we move on to some two-steps. This first one doesn't even look like a two-step to begin with. You might say that's not even a two-step, it's just a one-step. Well, it is a two-step. We'll talk about why it's a two-step in a second. But all of these are two steps. What that means is on all of the checks, you should have the original written down, then you plug in, then you do some work, then you do the rest of the work. So if your check doesn't have 4 lines on all the two steps, they only have 3 lines, it means you probably did not check correctly, you did not actually check. I would imagine you're going to lose points because you did not actually show the work of checking. Let me show you why this is a two-step. 4 minus x, you might say, oh, it's subtraction, so let me add 4 and add 4. If you add 4, 4 plus another 4 is 8 minus x equals 10. You actually didn't solve it, you made it worse. Again, the 4 is not negative. What's negative is the x. So how do I get rid of this positive 4? That's when I subtract 4. Subtract 4. 4 to negative 4, these two cancel each other out because one's positive, one is negative. 6 minus 4 is 2, and it's a negative x. Again, the x is negative. I thought that was subtraction. Again, keep, change, change. It is a negative plus a negative x. It is a negative x. As you can see, the x is negative. I get rid of the 4, but I subtract the 4. All right, at this point, you may be confused. How do I solve this? Well, negative x equals 2. That just means there is a coefficient. We did this earlier in this study guide. There's a coefficient. The coefficient is negative 1. There's always a number. If you're not sure what it is, it's probably 1. Negative 1 times x, I divide by negative 1, divide by negative 1. X equals 2 divided by negative 1. 2 divided by 1 is 1. Sorry, 2 divided by 2. 2 divided by 1 is 2. 2 divided by 1 is 2. Signs are different negatives, so it should be x equals negative 2. Let me check to prove that this is correct. 4 minus x equals 6. 4 minus, everything stays the same, except x now becomes negative 2. So when I do keep, change, change to a positive 2, change it to a plus, change it to a positive 2, and I get 6 equals 6, check mark. There are my 4 lines. There are my 4 lines. There's a two-step. Minus 15, minus 15. Again, the 15 is positive, so I subtract it. I get just 2k equals 30 minus 15 is 15. Divide by 2, divide by 2, I get k equals, tricky one off the bat, 7.5. So k equals 7.5. Yes, it's okay to have a decimal. 7.5. Let's check my work. 15 plus 2k equals 30. Everything stays the same, except instead of k, I put 7.5. We're back to following order of operations. 2 times 7.5 is 15, so 15 plus 15 equals 30. 30 equals 30. Check mark. 7.5 is my answer. Notice again, 1, 2, 3, 4 lines. If you have only 3 lines, you probably didn't check correctly. There's a two-step. We got multiplication and subtraction. We undo subtraction first because it's reverse PEMDAS. It's SADMAT. 7p equals 14. Divide by 7, divide by 7. P equals 2. Let me check. 7p minus 7 equals 7. 7 times, again, everything stays the same except instead of p I put 2. Back to following order of operations. This is 14 minus 7 equals 7. Notice that the 7 comes down the whole time. There's nothing to do on the right side. 14 minus 7, 7 equals 7. Check mark. 2 is my answer. Another two-step. Minus 3, minus 3. X divided by 4 equals, gotta know how to work with integers, negative 2 minus 3. We don't do subtraction, we do keep, change, change. 2 negatives plus 3 negatives. 2 negatives plus 3 more negatives is negative 5. Now we undo division with multiplication, times 4 times 4. X equals 5 divided by 5 times 4 is negative 20. And now let's check. x divided by 4 plus 3 equals negative 2. Everything stays the same, except instead of x, I plug in negative 20. All right, negative 20 divided by 4. Well, 20 divided by 4 is 5. Signs are different, so it's negative 5 plus 3 equals negative 2. We like addition. These numbers fight. They kill each other. The negatives win because there's more of them by 2. Negative 2 equals negative 2. Check. Should actually see if your number makes any sense. Down here, negative 2n plus 9. Add 9, add 9. Negative 2n equals 27 plus 9 is 36. Divide by negative 2, divide by negative 2. N equals negative 18. Let me go back to this line, negative 2n equals 36. If you got here, it is very possible that you said, oh, I undo this by add 2. No, you don't. You don't undo multiplication with addition. You might say, well, that's a negative 2. Well, it's a negative 2, not a subtract 2. It's not n plus 2. It's negative 2 times n. I separate this multiplication, separate the n from the 2, which is held together by multiplication, by division. You divide by negative 2. That undoes this multiplication. We divide that side by negative 2. My answer is negative 18. Let's check. Negative 2n minus 9 equals 27. Negative 2. Again, everything stays the same except instead of n, I plug in negative 18. Multiplication comes first. Negative 2 times negative 18, and negative times negative is a positive 36 minus 9 equals 27. Notice 27 comes down the whole time. 36 minus 9, you could do that. You could keep change if you want, but 36 minus 9, 36 positive, take away 9 positive is 27 positive. Check. Negative 18 is my answer. The last one, you can certainly do this one by how do we undo subtract a negative 3? We add a negative 3. Undo subtract a negative 3 by add a negative 3. And we add a negative 3 to that side. 5 negatives plus 3 negatives is negative 8. I want you to remember that number, negative 8. Could be negative 8 on that side. Or you could have simplified this equation, because we don't like double signs anyway. H divided by 2, if you negative negative is a positive. Now it's much cleaner. Negative, subtract a negative 3 is keep, change, plus 3. Now it's a lot cleaner. So we do this. How do I do plus 3? Minus 3, minus 3. If h divided by 2 is, well, again, we don't do subtraction over here, so we do keep, change. They work together. 5 negatives and 3 negatives is still negative 8. So if you notice, either way, we still got to negative 8. You could have got it by doing, how do we undo subtract negative 3? We add negative 3. Or you could have shown that negative turns to a positive and then undone it that way. Either way, we're at the same spot. Continue solving, undo division and multiplication. H equals negative 16. Let's check this. H divided by 2 minus negative 3 equals negative 5. Everything stays the same, except instead of h, I use parentheses and plug in a negative 16. Negative 16 divided by 2, well, 16 divided by 2 is 8, and the signs are different, so it's negative. So negative 8 minus negative 3 equals negative 5. We don't do subtraction, we do keep, change, just like we did over there. They fight. The negatives win by 5 equals negative 5. Check mark. Negative 16 is my answer. Moving along to modeling. This big long guy means an x. This open one means a positive 1. This one means a negative 1. If it's x plus 5, it's a big long x. And then it's 5 positive. So I don't have to put a plus sign. As a matter of fact, you should not put a plus sign. If you put a plus sign, it's not correct. It's implied when we do, okay, plus 5. Just give me 5 of these guys. That's 1, 2, 3, 4, 5. An equal sign we do need, now it's 10 negatives, so it's 1, 2, 3, 4, 5. We need 10 of them. 6, 7, 8, 9, 10. How do we solve this? X plus 5 equals negative 10. Minus 5, minus 5. X equals, we don't do subtraction, we do keep, change. They work together, negative 15. Let's check this. X plus 5 equals negative 10. Negative 15 plus 5 equals negative 10. Notice that everything stays the same. But instead of x, I plug in what I believe the answer is. They fight. The negatives win by 10. Check mark. Negative 15 is my answer. The second one is the one I'm more concerned about because I often see students do this wrong. They see 3x. So what I see students do is they go, oh, here's 3 and here's x. Nope, this would be x plus 3 singles. That's not what we want. 3x is actually pretty easy. There's 1x, there's 2 x's, there's 3 x's. Now I need 6, so 1, 2, 3, 4, 5, 6 equals 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's solve. 3x plus 6 equals 12. Minus 6 minus 6. 3x equals 6. Divided by 3, divided by 3. X equals 2. Let's check this. 3x plus 6 equals 12. Everything stays the same, except instead of x I put 2. Notice that I use parentheses. 3 times 2 is 6 plus 6 equals 12, and 12 equals 12. Check mark. These last ones are word problems. They involve you translating, defining your variable, writing the equation, and solving. So they solve, first write an equation, then solve, and finally check. So we got write, solve, and check. Models meaning not like the models we just did, but like the equation demonstrates the situation. Let's do question number 1. At a restaurant, Scott and his 4 friends decide to split their bill evenly. Each person paid $20. How much was the bill? So what we're looking for is the bill. So the bill equals B. So what we're trying to do now is to find out if I took the bill, and I took the bill and I divided it 5 ways, so me and my 4 friends, Scott and his 4 friends, that's 5 people. If I took the bill divided by 5, each person paid 20. So I took the bill, split it by 5, that means each of us is $20. So the bill split 5 ways is $20. Bill is what we're looking for. So that's my equation. Bill divided by, 5 equals 20. Could you have written bill divided by 5 equals 20? Sure. If you did 4, you forgot about Scott. Now let's solve it. Bill divided by 5 equals 20 times 5 times 5. B equals 20 times 5 or 100. So let's see if that makes sense. Is $100 split 5 ways equal to 20? This is my check. So 100 divided by 5 is 20 equals 20. Yep. The bill was $100. The next one. Remember to define your variable first. You bought you and 3 friends Zynga over the weekend and gave a $5 tip. If you spent $21 total including the tip, how much was each Froyo cup? So if we want to know how much each Froyo cup was, let's say the Froyo cup, for the Froyo cup, we'll call that C. So that's what we're looking for, is the price of the Froyo cup. Now we know that the Froyo cup, it was you and 3 friends. So how many people is that? How many cups were bought? 4 cups. You and 3 friends means that 4 cups were purchased. So 4 cups. So 4 times whatever the price of the cup is, 4 of each of them, 4 times that, plus the $5 tip. That was a total of 21. There's a hint. 21 is the total, so when you add all this up, it equals 21. That's my total. Again, $4 per cup. Sorry, 4 of the price of the cup, so whatever the cup is, it's 4 times that price, plus the $5 tip is 21. That's my equation. 4C plus 5 equals 21. I could use this to solve. Let me erase it and rewrite it so I have some space. 4C plus 5 equals 21. Minus 5, minus 5. 4C equals 16, divided by 4, divided by 4. C equals 16 divided by 4, or $4. So it looks like it's $4 per cup. Let's think about that. If it was $4 per cup, it was me and 3 friends, so it's 4, that's me, 1, 2, 3 friends. Add these all up, it's 4, 8, 12, $16. Oh yeah, the $5 tip, it's $21. So that makes sense. That's not the official check. The official check should be write the equation. 4C plus 5 equals 21. 4 times C is, C is 4. So 4 times 4 is 16 plus 5 equals 21. 21 equals 21. The other way you really could have thought about this problem was if it was you and 4 friends and they each got a cup. So this C represents my cup. This C represents my friend, my second friend, my third friend, plus the $5 tip. That added to be 21. Well, C plus C plus C plus C, this is 1C plus 1C plus 1C plus, that's 4C plus 5 equals 21. It's the same equation. Let's move on to the last question. It says, Ryan had $100 to spend to get 45 Chick-fil-A sandwiches for the snack shack at the football game. When he received this change, he had $10 left over. How much was each sandwich? So that's what we're looking for. So the sandwich we'll call S. That's what we're looking for, the price of the sandwich. That's the variable we're defining. We had $100 to spend to get 45 sandwiches. So let's find the price of the sandwich. So it's $45 per sandwich. Sorry, 45 times the price of the sandwich. So it's 45 S's. I can't really do the same thing here because I would write out 45 S's. It would take forever. 45 S's, 45 sandwiches, plus his $10 tip. Sorry, the $10 change equals $100. So we had $100. Some of the money was spent on the sandwiches, plus there was 10 left over. So if you put this all together, that's $100. 45 times the price of the sandwich, plus the $10 that was left over, that's his full $100. Again, 45 sandwiches plus the $10 left over is the whole total $100. 45S plus 10 equals 100. Let's actually solve this. So 45S plus 10 minus 10 minus 10. 45S equals 90. Divide by 45. Divide by 45. S equals 2, if you can see that down there. So the price of the sandwich should equal $2. Does that make sense? If you got 45 sandwiches each at $2, well, 45 times 2 is 90 plus the $10 change. Well, let's check it also doing this. 45S plus 10 equals 100. 45, the price of the sandwich is $2. Let's see if that makes sense. Get 45 of the $2 sandwiches. Again, 45 $2 sandwiches is 90 bucks plus the $10 change. That fully accounts for his $100. Check. So the price of the sandwich must have been $2.